In this video, we're going to begin section 17.2 on motion, velocity, and acceleration. So let's begin with the definition, and that is of a velocity vector. First, we have to do a little bit of setup here. So let's let r of t represent the position vector of an object at time t. So if we look here at the right of this graph, so here we should imagine that this curve is our curve parameterized by r of t. Okay, so then the derivative, r vector prime of t, is given by the formula that's stated here. So that is r prime of t is dr over dt, which is the limit as h goes to 0 of the difference of r of t plus h and r of t over h. Now, the velocity vector of the object at time t, denoted v of t, is defined by the derivative of r of t. In other words, the velocity vector is the derivative of r at t. All right, so let's just unpack this a little bit, just so we can see what's actually going on here and how to think about it. So if this is our curve over here, where you see that I have some arrows already drawn, but let's draw in a few more. So let's let this point here be the point when t, or starting at t. So meaning that I can draw in the vector from the origin to the point, and that is my vector r of t. And so then as I move along the curve, so this could be, say, this point here could be the point r of t plus 1/4. This could be the point r of t plus 1/2. This could be the point r of t plus 1. So as I move along this curve, I trace out the curve as indicated. Here's my r of t. So then here, as I move along, I get these other r of t vectors. Okay, so let's just compare the largest two. So r of t and r of t plus 1. So when I subtract, so take the difference, r of t plus 1, say, minus r of t, what that is the vector ending at r of t plus 1, moving to r of t. So this vector here is the vector r prime of t, or r rather, of t plus 1 minus r of t. And so what happens here as 1 gets smaller, or that we can even generalize to h, as h gets smaller, my vectors get closer and closer to that point at r of t. So maybe say another way, these red vectors that are drawn in are those differences between r of t plus h and r of t. I'm going to clean this up so we can see that. So here, these red vectors, those are the difference r of t plus h minus r of t. So as h gets smaller and smaller, notice what happens to our vectors, but they get closer to starting at this r of t, and then almost just projecting off the curve like a tangent line. And so then with some scaling involved to determine kind of that speed, we get the velocity vector itself. Okay, cool. So what about actually computing this vector? Because this involves a limit with vectors. So how does that computation actually work? Well, it turns out it's as simple as taking the derivative of each component. So the next theorem, we are given that r of t is the parametric equation x of t I plus y of t j plus z of t k. And we're told it's the position vector of some object at time t. So meaning our object is tracing along or moving along that curve in this manner. Then the velocity vector or r prime of t, is given by x prime of t, I plus y prime of t, j plus z prime of t, k. So it's pretty much everything we've hoped for. We just need to compute the derivatives of each component to determine the derivative of the entire position vector. And so just to use that language, this is the velocity vector. Okay, so one more definition to leave us with, and that is acceleration vector. So as you might suspect, the acceleration vector is given to us by the derivative of the velocity vector. But let's read together. So it says the acceleration vector, often denoted a vector of t, of an object with position r of t is defined by, well, that acceleration is going to be the derivative of the velocity vector, which is the second derivative of the position vector. And one other definition here relating to that velocity vector, we can compute the speed of the object. That is going to be the length of that velocity vector. So the velocity is a vector. So it gives us a magnitude and a direction, but the speed just tells us the magnitude. Awesome. All right, great work going through this little summary of chapter 17.2 on motion, velocity, and acceleration.